sub O versus V sub I, using a model of semiconductor diode. Model of semiconductor diode. Is an ideal diode. We have a triangle touching the vertical line, series with a battery, with B gamma volts. With B gamma, you'll be told is 0.65 volts. And so, what we want to do is come up with equations that will tell us what's the voltage drop across the ideal diode for certain conditions of the input voltage. So if I replace this semiconductor diode with this model of an ideal diode in series with a battery B gamma volts, I'll change this to an ideal diode. I'll just add a voltage of B gamma to this. Now all we have to do is write Kirchhoff's voltage law around this loop, solve for the voltage drop across the ideal diode. It's not really necessary once you get used to it to go through the circuit analysis. You just look at it, you can tell what's going on. What's going on is that ideal diode is going to reverse bias, so E sub I is positive, equal to E sub O plus B gamma. So, if we go around the loop, we get E sub I is equal to the diode current, ID, which is this, from top to bottom, times the total resistance of the circuit, which is R1 plus R2, plus voltage drop across the ideal diode, plus E sub O plus V gamma. Solve for VD. We get that VD is equal to V sub I minus E sub O plus V gamma minus ID times R1 plus R2. Now the current, ID, is either going to be 0 or a positive number. It can't be negative. It can't be negative because the orientation of the ideal diode. You can't get current flow in the counterclockwise direction of that circuit due to the orientation of the ideal diode. So this term is either going to be 0 or negative. This term is negative. So the voltage drop across the ideal diode will be negative until V sub I is equal to E sub O plus V gamma. So VD will be less than 0 for V sub I less than E sub O plus V gamma. If that's the case, it's an open circuit. An open circuit, no current flow in the circuit. So what's the voltage drop? V sub O. V sub I is less than E sub O plus V gamma. What current flows in the resistor R1 for V sub I less than E sub O plus V gamma? There's no current. The ideal diode is reverse biased. There's no current. What's the voltage drop across resistor R1? 0. That means the output and the input voltage are the same. So it's a straight line with a slope of 1. Going through the origin. Once V sub I is equal to E sub O plus V gamma, the ideal diode switches from an open circuit to a short circuit. Once it switches to a short circuit, we just replace it with a short. We've got a circuit with 2 voltage sources and 2 resistors. You can solve for V sub O. If you want delta V sub O divided by delta V sub I, since this isn't changing, we can replace it with a short. We've got a 2 resistor voltage divider. We've got a straight line with a slope equal to R2 over R1 plus R2. Okay? So let's look at this thing and see what we see. There are 2 straight line segments. It's continuous. And at the point where the ideal diode switches from an open circuit to a short circuit, that's where the slope of the straight lines change. Now, if we ungrade this, you're going to get certain levels of partial credit. You'll get maximum credit, of course, if you get the right answer. And there's a very limited demand in the industry for people who have degrees from Georgia Tech to get the wrong answer. They want somebody who's going to get the right answer. That's why they hired you in the first place. So I will be given levels of partial credit. If you draw something, the slopes are wrong, the shape's wrong, and the breakpoints are wrong, everything else is about as wrong, I will give you a certain amount of partial credit. You have a continuous plot. If you want very little credit on this, if you just draw in something like this, like the brainwave pattern of a Georgia Tech administrator, you're not going to get very many points, okay? It has to at least be continuous plot, okay? Now, that brings us to problem 4, which is, of course, my favorite problem. Single capacitor buildings. Also a problem that we had on lecture exam too. We'll be given a circuit of some kind. As to determine complex transfer function in terms of the symbols or the circuit components okay? Well, the first thing we have to ask ourselves is what type of filter is it? Okay? In order to do that, we need to know its transfer function is.